Hi everyone, welcome to the math stage. In today's video, we'll be looking at multiplying algebraic fractions. In the last video, we looked at addition and subtraction of algebraic fractions. If you missed that, there'll be a link in the description below so you can catch up. Now, please remember to like, share, subscribe, and leave a comment to let me know what you'd like to see next in math. Let's get straight into it. As you can see on the screen, we'll be looking at 6 examples, all of which are different, so please ensure to watch the video to the end. When multiplying algebraic fractions, you want to factorize the numerator and the denominator. You want to cancel any common factors. Then you go ahead and multiply numerator with numerator and denominator with denominator. Let's get into it, beginning with example number 1. Example number 1, 6x over 2y times 4y over 5. The first thing, let's go through the steps. Is there anything for us to factor? The answer here is no. Next thing, can we cancel? Yes, we can. So we're going to go ahead and cancel all the common factors. So 2 can go into 2 one time, and 2 can go into 6 3 times. Y here can cancel y here. Is there anything else for us to cancel? No, there is not. So we're going to go ahead and see what we're left with. We're left with 3x over 1 times 4 over 5. Since there's nothing else to cancel, we're going to multiply to get our answer. So 3x times 4 gives us 12x. And 5 times 1 is 5. And that is our final answer. Example number 2, 64xy squared divided by 9y multiplied by 3x cubed divided by 16x squared y. First thing, can we factor anything? No, we cannot. But we do realize that in this example, we're working with exponents, and for this specific example, we're going to write out the exponents to let it be a bit simpler for us to understand. So we can see all the different parts of the exponent. Let's go ahead and cancel the common factors here. So y here can cancel y here, and y here can cancel y here. This x can cancel this x, and this x can cancel this x. Is there anything else that we can cancel? Yes, there is. 3 goes into 3 one time, and 3 goes into 9 3 times. 16 goes into 16 one time, and 16 goes into 64 4 times. Let's see what we're left with. We're left with 4 over 3 times x squared over 1. Since there's nothing else for us to cancel, we're going to go ahead and multiply. And our answer is 4x squared over 3. 4 times x squared gives us 4x squared, and 3 times 1 gives us 3, leaving our answer at 4x squared over 3. Example number 3, 2a over 4b squared times 5b over 3a. Simple enough. Looking at it, we understand there's nothing for us to factor, but what we can do is definitely cancel. So 2 into 2 goes 1 time, and 2 into 4 goes 2 times. Anything else that we can cancel? Definitely. This b will go into itself once, while it will go into b squared, leaving us with b. And this a will go into itself once, while it will go into a cube, leaving us with a squared. It's as simple as subtracting. This a has a power of 1, which is equal to a. A cube has a power of 3. When dividing, we would say 3 minus 1 equals 2, leaving us with a squared, as we would keep the base. And the same thing for b. This b with a power of 1 is equal to b itself, and b squared has a power of 2. When dividing, it would be 2 minus 1 equals 1, leaving us with b to the power of 1, which is also b itself. What are we left with? We are left with 1 divided by 2b times 5 divided by a squared. Let's go ahead and multiply to get the answer. So 1 times 5 is 5, and 2b times a squared is 2a squared b. And this is our final answer. 1 over 2z plus 5 multiplied by 3z over z minus 1. What's the first thing that we realize? This example is different from the first three, but it's still simply enough for us to work it out. No. Is there anything else for us to factor? Is there anything to factor? No. Is there anything to cancel? No. You might be thinking, but there's a z here, and there's a z here, and there's also a z here. Why can't these cancel? Simply because we can't pull the z's out of these expressions to cancel it with this one. So we can't cancel anything. Okay, moving on. We can't factor and we can't cancel. What is next? Next, we simply go ahead and multiply to get our answer. So 1 times 3z gives us, and 2z plus 5 times z minus 1 gives us, simple, 2z plus 5 multiplied by z minus 1 in brackets, and we don't need to distribute the brackets. This right here is our final answer. T squared plus 5 over 12 times 4t cube over 1 minus t. What to do here? Anything to factor? No. Anything to cancel? Most definitely. 4 goes into 4 one time, but 4 goes into 12 3 times. Anything else to cancel? No, because we can't pull this t out and this t out to cancel it with this t. So nothing else to cancel. What are we left with? Now we'll just go ahead and multiply to get our answer. And this is our final answer. T cubed multiplying t squared plus 5 all over 3 multiplying 1 minus t. Number 6. X minus 2 over x squared plus 6x plus 8 multiplying 2x plus 4 over x squared plus 2x minus 8. Looking at it, we already know there's a lot for us to factor, so let's get right into the factorization. Starting with 2x plus 4. What is a common factor for both the 2x and the 4? You're right, 2. So 2 divides into 2x leaves us with x. Put back our plus sign, and 2 divides into 4 leaves us with 2. So on the first quadratic. What two factors of 8 when multiplied will give positive 8, but when added will give positive 6? Correct. 2 and 4 both positive. Let's input these as coefficients of x. Now let's factor. Here we can pull out x, and x divides into x squared leaves us with x. X divides into 2x leaves us with 2. We put back our plus sign. The common factor here is 4. 4 divides into 4x leaves us with x. 4 divides into 8 leaves us with 2. And our factors are x plus 4 into x plus 2, our second quadratic. Which two factors, when multiplied, will give negative 8, but when added, will give positive 2? You are correct. That is positive 4 and negative 2. Let's input these as coefficients of x. Let's factor. So the factors of the second quadratic are x plus 4 and x minus 2. Let's put these back into our problem. Now, looking at this, is there anything for us to cancel? Yes, there is. X minus 2 cancels x minus 2, and x plus 2 cancels x plus 2. What are we left with? Let's multiply to get our answer. 1 times 2 gives us 2, and x plus 4 times x plus 4 gives us x plus 4 squared. And this is our final answer for final example, 2 over x plus 4 squared. Thank you for watching our video here at the math stage. Remember to subscribe, share, and leave a comment. Please let me know what you'd like to see next. Thanks and bye for now.